Let's now talk about visualizing these polynomials. In the last section, we saw how easily we could plot these polynomials, right? Now we would be able to derive some useful insights about polynomials when we start visualizing these polynomials. So let's discuss these things in detail. In this video, we will be focusing on graphing linear polynomials. Let's say we want to plot the linear polynomial p of x equals 4x minus 2. Now to plot this, all we have to do is to take some random values of x and find the corresponding values of p of x. So let's do that quickly. So let's draw a table like this. Take some random values of x, let's say minus 1, 0 and 1, and calculate the corresponding values of p of x. Remember, p of x can also be thought as y. When x equals minus 1, the value of p of x is minus 6. When x is 0, the value of p of x is minus 2. When x is 1, the value of p of x is 2. So we now have few x values and their corresponding y values. So let's plot these points in the xy plane and see what we get. So the points that we obtained are minus 1, minus 6, which is here, 0, minus 2, which is here, and 1, 2, which is here. Now let's connect these points and see what we get. So what do we get here? Yes, we get a straight line. In fact, you graph any linear polynomial, what you get will be a straight line. That is why linear polynomial are called so. The graph of linear polynomial will always be a line. So what's the advantage of drawing a graph? The advantage of drawing a graph is that you can find the value of p of x for any desired values of x. For example, let's say you want to find the value of p of x when x is equal to 5. So all you have to do here is to extrapolate this line that you just created and see the value of p of x when x is equal to 5. When you do that, you will get the value of p of x as 18. Now looking at the graph, can you say what is the 0 of this polynomial? Remember, 0 of the polynomial is defined as that value of x at which the value of p of x becomes 0. Now if you observe carefully, you can see that the value of y or p of x becomes 0 at this point. Now what is the value of x at this point? The value of x here is 1 by 2. So we say that 1 by 2 is 0 of the polynomial 4x minus 2. So let's understand this clearly once again. How do we find 0 of the linear polynomial? By looking at the graph. All we have to do here is to look at the graph and see at what point does the line crosses x-axis. The x-coordinate of this point where the line intersects x-axis is 0 of the polynomial. Now, is there any other point through which the line cuts the x-axis? Now, that's not possible, right? Because since this is a line, it can only cross x-axis at one single point. Which means we can say for a linear polynomial, there will be a single 0. We just found out 0 of the polynomial 4x minus 2 as x equals half geometrically. Now let's confirm this result algebraically as well. So how do we do that? We are interested in that value of x when p of x becomes 0. So to find this, all we have to do is to equate p of x to 0 and solve for x. So let's do that. So we need to equate 4x minus 2 equal to 0, and then when we solve for x, we will get the result as x equals half. In general, a linear polynomial is given as ax plus b. Now to find the 0 of this polynomial, all we have to do is to equate this polynomial to 0 and solve for x. Now when we do that, we get the value of x as minus b by a. What does it mean? It means that just by looking at the coefficient and the constant value of the polynomial, we will be able to determine the zero of the polynomial. Consider the example that we just discussed. P of x equals 4x minus 2. In this polynomial, the value of a is 4 and value of b is minus 2. And just now we discussed that zero of the polynomial is given as minus b by a. Now when we apply that here, we get the result as x equals half. So let's quickly summarize what we did in this section. In this section, we discussed 3 ways of finding zeros of a linear polynomial. Firstly, we plotted the polynomial in a graph and then found out zeros of the polynomial. And how do we do that? We just need to look at the point on the x-axis through which the line passes. The x-coordinate of this point will be 0 of the polynomial. Secondly, we solve for x by equating the polynomial to 0. And lastly, we saw that we can just use the coefficient and constant value of the polynomial to find 0 of the polynomial. 0 of the polynomial is given as x equals minus b by a. So that's all about graphing linear polynomials and finding zeros of the linear polynomial. In the next section, we will see graphing quadratic and cubic polynomials and then also draw insights about the zeros of those polynomials.